Okay, thank you, Steve. So what I'll say is I'll be going through the slides. I won't be stopping for questions as I go along. If you do have any questions, please use the questions section at the top of the screen. Steve will try and answer as many questions as we can as we're going through, and I'll pick up any remainder towards the end of the session. So what we're going to talk about is StoreOnce Catalyst. I'm going to talk about why we're introducing a new interface. I'm going to talk about a couple of the features that Catalyst brings. We'll cover licensing, manageability. We'll cover the compatibility, so which applications, which OSs are supported. We'll spend some time looking at the new web management pages for Catalyst. I'll cover the support tickets and what you can expect to find in there that's specific to Catalyst. And then we'll finish off by reviewing the backup applications and which features are supported by which ones. So the D2D backup systems at the moment feature virtual tape library emulation and network attached storage emulation. And these have some limitations that many customers come across. For example, the library geometry needs to be defined up front. So you need to choose which virtual library you're going to emulate. You need to choose how many tape drives it's going to have, how many cartridges, what size cartridges. And ultimately, these are fake limitations that we're imposing. With NAS, the implementation that we have on the D2D StoreOnce products has a limitation of 25,000 files and or folders per share. Which seems like quite a number of backups, but depending on which ISV application you're using, that number can be relatively easy to achieve, and then you're having to create another NAS share, which then means a new deduplication pool in which for that to be stored. So you kind of lose some of the benefits of dedupe. And again, both of these limitations, be it the library geometry limitations or the files and folder limitations, are not necessarily a limitation of dedupe itself, but they're a limitation of how we do the emulation, what we present to the ISV applications. Now, in addition to this, many of the more advanced features that we have within our StoreOnce products, for example, deduplication and also replication, these features are hidden from the ISV applications. So that means that they can't report on these, they can't make decisions based on what's occurred. And that means that we don't get a holistic view for the customer. They're having to do management of their data backups through their ISV, but then also monitoring and configuration of replication through the D2D appliance. So the new interface that we're bringing in is called StoreOnce Catalyst, and what we do is we're aiming to address some of those limitations. So first of all, it's a new device type that the ISVs can use. So it doesn't have any geometry limitations. We're not trying to emulate anything physical. It's a complete build from the ground up. It's an RPC protocol-based interface. So it's designed for use on the Ethernet ports of the StoreOnce appliances, not fiber channel. But the intention here is to give ISV applications complete control of the D2D backup device. So we allow them to see that we are a deduping appliance. We allow them to see whether the deduplication is being effective on particular backups or not. We provide them with the capability to see what copies there are of different backups. And as I say, we're using an RPC-based protocol, and it's a custom protocol that we've defined for StoreOnce Catalyst. Now, doing this allows us to do things like implement bandwidth efficiency within our protocol. For example, our protocol has compression enabled by default within that. We also have a pre-processing for dedupe that again can reduce the amount of data that actually needs to be sent over the network to the StoreOnce device. So that gives us a few things. Increased backup performance because we're no longer sending quite as much data to the D2D. It allows us to do things like backups over a WAN connection, because again, if we don't need to send as much data, then the size of the link is not necessarily needing to be quite as big. and it allows us to do things like optimize copies, no longer having replication be a sideband mirroring of one store into another store. We now expose all of our stores to the backup applications, and that allows the backup application to specify which backups get copied and when. So all in all, the thing to take away from this is that we're providing the ISV applications with full control of their data. As a StoreOnce Catalyst device, we don't understand the ISV backup formats, with no intention of understanding the ISV backup formats. It's their data. They know what to do with it. They know when the customer wants to expire it. They know how many copies want to be made. So really all we're doing is putting that control back with the ISVs. Now the RPC protocol obviously needs both ends to talk the same language, to understand the RPC calls. And so what we're doing is we're shipping the Catalyst Client API or the Catalyst Client library. That'll be shipped as part of backup applications. So for example, Data Protector 7 includes a Catalyst library in there, which allows Data Protector 7 to talk to the StoreOnce Catalyst devices. Now, as you can see in this very simplistic diagram here, the green code is the Catalyst specific code, the backup application being the salmon color there. Now, two big features that we have. The first one is Dedupe Pre-processing. It's known by many different names. We'll cover some of those in a moment or two. But essentially what we're doing here is we're taking some of the deduping steps and actually distributing those out, specifically the chunking and hashing. Now doing this, chunking and hashing across multiple servers instead of the one D2D, actually shares out what is considered to be a processor-intensive task. Now, if you spread out that among multiple media servers with multiple CPUs, and each CPU, the sum of all the CPUs, should I say, is greater than the sum of the CPUs within the D2D appliance, you can see how a CPU-intensive task could be sped up by distributing that load. And now one of the other benefits of distributing that to the media servers is we also then reduce the amount of data that needs to be sent to the D2D. So as I mentioned, reducing that amount of data reduces the requirement of the network. It reduces the load on the network. So you can perceivably get more through on the network. If you've got a 10 gig network, for example, you're going to saturate that network at about 1.2 gigabytes a second of throughput. Now, if you can reduce the amount of data that actually goes onto the network, the physical transfers, then the logical throughput could far exceed that. And in many cases, we've seen as high as 3.5 gigabytes of throughput with real user data. Again, as I specified, because the requirement on the network could be significantly reduced, especially if you've got a large amount of common data and you're able to do the pre-processing, it is also possible to configure this low bandwidth mode or the Dedupe pre-processing for small remote sites. So you wouldn't necessarily have to have a D2D in that particular location. You could have the media server in the remote office actually sending over a WAN link to a StoreOnce appliance in the data center. Now, I have noted on this particular slide that due to latency and the size of the link, you may find that this doesn't scale indefinitely. We're not talking about having one data center have media servers that are ultimately backing up to a separate data center. It doesn't scale to that kind of size, but certainly for the small to medium office, it's certainly an option. Now, the text here probably doesn't paint a particularly good picture of what's going on, so hopefully this slide helps a little bit here. Those of you that are familiar with the dedupe process will be very familiar with the terms chunk, hash, match, compress, and store. But for those of you that aren't, essentially what we're doing is we're taking the data stream in here. And if we look at the target side deduplication at the top, we've essentially sent all of our backup data from the client over to the Catalyst store. As that data stream comes in, we're then chunking that up. So we're slicing that data stream up into smaller, more manageable pieces. What we'll do then is we will calculate a hash based on that chunk of data, and then we will take that hash and we will match it to see if we've ever seen that hash before. Now, if we have seen that hash before, we will respond, or if we have seen that hash before, then we won't need to store the data. If we haven't seen that hash before, what we'll do is we'll then request that data, we'll then compress it, and we'll finally store that data. Now, as I say, the chunking and hashing process is quite a CPU-intensive task, along with compression. And so what we're doing is we're moving those over to the client. So in the source side deduplication that we have at the bottom, here we can see we still take in the data from the buffer, so it's one long stream of data that's coming in. Again, we're now chunking up that data, but this is now done on the client or the media server. Again, we do the same hash calculation, but this time we now send the hashes over to the Catalyst store, which obviously hashes themselves are only very small representations of a chunk of data, so it doesn't take up much bandwidth at all. We do then do the matching on the D2D appliance within the Catalyst store. We then send back a list of the chunks that we do not have matches for. The Catalyst client then will compress all of the chunks that need to be sent over, all of those unique chunks, and finally we'll then store those chunks on the D2D. So you can see all the steps are exactly the same in both the target side deduplication or the source side deduplication. All we're really doing is moving the location of where that work is actually done. Now, in this particular slide here, we can see that we're showing multiple media servers configured up. So this is just a very simple example of how this could be deployed in a data center. So you've got a series of clients that you need to protect. The blue lines here representing a high bandwidth network, be it a 1 gig network or a 10 gig network, but something that all the clients will be backed up over. The media servers then are connected up to the D2D appliance, again using a 10 gig network, for example. But in this particular example, we're now doing the pre-deduplication processing on the media servers. So the green lines here represent the fact that we're not sending all of the hydrated data to the Catalyst store. So we're not limited by the 10 gig network. We're not limited to a 1.2 gigabyte throughput. We can actually get a logical throughput much higher than that, because the amount of data would only be a fraction. We're only sending the unique parts of the backup stream. So we expect this to be a very, very common deployment. Now, for those of you that are familiar with data domain products, you may have seen this or a very similar concept referred to as Boost. Essentially, this is exactly the same thing. It's just the way we've implemented it as part of the HP StoreOnce Catalyst vision. Now, going back to the remote office, so in this particular example we see here, we've got the clients. Again, they're all being backed up via the media server. In this particular example, you see that because we're only sending the unique data over the green line, that can actually go over the WAN, and we see here that the Catalyst store is located in a different location to where the media server is. Now, as I said, there's several different terminologies that are being used for deduplication. The ones we use within the R&D community to allow us to differentiate where the deduplication is being done are as follows. So the target side deduplication effectively means that we're doing the chunking, hashing, matching, compression, and store all on the StoreOnce backup system. So from the client via the media server to the backup system is all high bandwidth. All of the data is sent in a hydrated form. Now, what we've just looked at is server-side deduplication. So the client itself sends the full data stream to the backup application media server. That then does the chunking and hashing and compression, and only the unique data then gets sent to the StoreOnce backup system. Now, as you can see, logically it then follows that if we were to put the same code onto each individual client, we will be able to do the chunking and hashing on any number of clients, sending only the unique data to the StoreOnce backup system. And this is referred to as source-side deduplication. And this is a feature that you'll find in Data Protector 7. So say there's a couple of features that Catalyst brings. The pre-duplication is one of them. The other thing we think a lot of customers will be particularly pleased with is the ISV control of data replication. So the backup data itself, as we've already explained, it's only really useful to the ISV application. No one else can really do anything with it. They're in custom formats. There are headers involved in there. You really need to understand the data stream that's been written to be able to do anything useful with it. Now, the backup data is only useful to an ISV application when it knows about it. And this is important. So for those of you that are familiar with the replication model of our current D2D products, you'll know that that's an out-of-band replication. Effectively, we have mirroring. So anything you do on the source side will affect the target side. So if you configure a source side library and you configure it with 8 cartridges and then tell those cartridges to replicate to a target library on another D2D, any changes you make to the source side library will then be automatically made to the target side library. That includes expiry of data, writing data, overwriting data. Everything that happens occurs on the source will occur on the target. And this is effectively known as mirroring. Now this is great, except that the ISV application is only aware of the source side library. It's not aware of the target side library. Now what this means is if an ISV application, what this means is if the source side library for any reason becomes unavailable and you want to recover the data from the target side library, one of the first steps that you need to do is make the ISV application aware that that data exists in the target library. Now, one of the common ways of doing this is to import the data in the target library into the ISV, make it aware that that data is there. Once it's imported that in and it knows about it in its catalog, it's then able to do recoveries from that. Now, different ISVs implement this in many different ways, but quite commonly to import those cartridges requires that the entire cartridge is read by the ISV application, which if you're wanting to do a recovery because your source side library's gone down and you urgently need to get your backups back, that can be a delay that you're not really looking forward to, because effectively you'll have to read the entire backup first to get it into the catalog, and then you're going to have to read the entire backup again to do the recovery. Now with Catalyst, that all changes. We put the control of replication, or as we call it, Catalyst optimized copies, into the control of the ISVs. This means that the ISV application gets to control what's copied. We don't specify up front which cartridges or which objects will get copied from sources to targets. That's the decision of the ISV application. The ISV application gets to control when it's going to be copied. So no longer do we just automatically copy every cartridge or every file as soon as the backup application has finished writing the initial data. Now the ISV application gets to choose when those copies are made. It could be that you copy the backup immediately, that it's finished backing up. It could be that you only copy it to another location when you're wanting to archive it and you no longer need it for the immediate recovery. The options are really up to what the ISV applications can imagine. Now, unlike replication, which is a single source and a single target for the mirroring, with StoreOnce Catalyst, the ISV application can actually make as many copies as it wants, and it can make as many copies in as many locations as it wants. Again, this is really now down to the limitations of the ISV application as to how many they're able to track, and not necessarily limited to the D2D's ability to do replication between multiple locations. Now, another important feature here is because the ISV application created the copies when it chose, and it decided how many copies to choose. Each copy is individually known about via the ISV application. The ISV is now able to expire any one of those copies when it chooses. So if you wanted to have at your remote site, for example, data expiry after 4 weeks, but at your central data center you wanted to keep them for 1 year, and then in some vaulting archive you wanted to keep them for 10 years, that's perfectly possible using StoreOnce Catalyst. That's not a feature that's available with our current replication. So again, if you want to take anything away from this, the key thing here is the ISV application will be in full control of its data. It controls what's copied, where it's copied, when it's copied, how many are copied, and when those are expired. So walking through a couple of the scenarios where you would see copies deployed, the most simplistic, 2 data centers. This could equally be a remote office and a data center. In this particular example, you see how we have a media server on the remote site or the data center number 1, and it's going to control backups from the file server or the clients that are on there, and it's going to be storing all that information in the StoreOnce Catalyst store on D2D number 1. Now the ISV, once it's configured those backups and it's run those backups, it will then choose to do copies to the second Catalyst store that we see in data center number 2. And this is done in a bandwidth efficient way. So just like replication, it only transfers the unique data from one store to another. Now you may think that it needs to be the media server that did the backup that then does the copy, but that's not strictly the case. In many cases, you'll actually find that the media server that does the backup at the remote site or in the data center number 1, its sole job is to run backups. That's all it does during the backup window. And actually, you have a second media server that's then responsible for controlling when each of those copies comes into the central data center. And so you could easily have a second media server control the copy of the data. Again, this is really down to the ISV implementation. Now, unlike replication, where we say we only have a single source and a single target, again, in this particular example here, we're now seeing how we can do a multi-hop. Now I've shown 3 hops here, or 2 hops from 3 data centers. So we do a backup to the Catalyst store on D2D node number 1. We then do a copy to D2D node number 2. And then we do a copy from 2 to 3. Now, this is actually n number of copies. So this linkage could keep on going. It's really down to how creative you want to be with your backup policies, how many backups or how many copies you actually want to create. Many of the ISVs will allow you to create a double-figure number of copies should you choose. Now, just like you can do multi-hop, you can also do a one-to-many. So in this particular example here, we can see how we've done a backup to the Catalyst store on D2D node number 1, and then we'll instigate a copy to the Catalyst store on D2D node number 2. And once that's complete, we'll then do a copy from Catalyst store number 1 to Catalyst store number 3. And again, this is a 1-to-n, so it's only limited by the imagination of your backup policy as to how many copies you want to have. And as you can imagine, it will be very easy to implement a backup policy. There was actually a combination of both the one-to-many and also the multi-hop combination. So one of the main reasons for wanting to move copies to another location is for disaster recovery, but also for archiving purposes. So in this particular deployment here, we can see that we're actually moving copies of the backups to the second data center. And then we have a media server that's going to be responsible for then taking those copies and archiving them off to tape. Now, it's important to note here that the tape library is not directly connected to the D2D. And what's actually happening at the data center number 2 is once the copies arrive in the Catalyst store on D2D node number 2, it's actually the media server's responsibility to then do a rehydrated copy of that data off to physical tape. Now what this means is the copy of the data that lands on physical tape will actually be in a format where it can be recovered without having to go back via the Catalyst store. So these are not Catalyst-specific copies, they are independent copies that will be uniquely tracked within the ISV application. Now, all the examples that I've shown so far, you will have noted at the bottom that they were all within a single backup domain. So we just had a single master server or a single cell manager responsible. We only had one catalog, but it's equally perceivable that you would have copies going between cells or between backup domains. So in this particular example here, we're showing how if you have a Catalyst store that exists within two backup domains, you use this as a gateway. You can actually take your remote site that's in backup domain number 1, perform your Catalyst optimized copy to your D2D store using a process like the Symantec automated image replication, or AIR. You'll be able to then discover that the copy has landed in D2D node number 2, and the second master server then will be able to trigger an import of the catalog information and then trigger the copy over to the physical tape library. So as I'm sure you'll agree, what's being provided with the Catalyst store copies is far superior to replication in the way that it's now under the control of the ISV. We don't require any additional third-party scripts or monitoring tools to be in play to be able to track when these copies have occurred, to have the ISV applications be monitoring for changes on a library to see if there's anything it needs to import. We actually put the control of this back into the control of the ISV applications, the backup applications, and we get a much more seamless method of moving data around. So it makes it a much more cohesive interface for the customers to have to manage. Now, the StoreOnce Catalyst feature is a licensed feature. You don't get things for free. So there will be separate Catalyst licenses available for each of the backup application vendors. So there will be a license for HP Data Protector, and there will be a license for Symantec OST. Now, there will be a single license that will actually cover Backup Exec and Net Backup. So you'll be able to use either of the Symantec products with the Symantec license, and you'll be able to use HP Data Protector with the HP Data Protector license. Now, these licenses are specific to the D2D StoreOnce appliances. So these licenses are not to enable options within these applications. If you wish to use the Catalyst feature within Data Protector, for example, you will need the Advanced Backup to Disk license. If you want to use Symantec Backup Exec or Symantec Net Backup with Catalyst, you will need to have the OST license. Now, license enforcement, we've kind of got two strategies here. With the multi-node products, so the B6200 specifically, which we're talking about today, licensing will not be an enforced license. So you will be required to have a license to use the feature, but actually we won't prevent you from using the feature if you do not have a license. What you will find, though, is you will be nagged on a daily basis if you're using a feature for which you do not have a license. The reason for this is it allows our enterprise customers to get their systems deployed very easily, and we all know what good citizens they are, and they won't use features without licenses. When we have StoreOnce Catalyst on the single node products, this will be an enforced licensed feature. Now, what that means is if you do not have a license to use the feature, the stores will effectively be read-only. You will not be able to create any backups in the stores. You will not be able to create any new backups within those stores. You will not be able to copy anything into these stores. However, if you already had a license, it's been revoked, or you had an instant-on license, for example, and the license has expired, what we won't do is prevent you from getting to existing data that's on those stores. So effectively what it's going to do is it's going to become read-only. That means we'll allow you to read the data to do recovery. We'll allow you to copy the data off so you can migrate it to another location. And we'll also allow you to clean up that data. We'll allow you to delete the data or expire the data that exists within those stores. So you can see slightly different strategies for the multi-node and the single node products, but they effectively will use the same licensing model. Now, I'm not going to talk about manageability for too long, as we'll actually delve into the GUI itself and have a look round. Just to give you an overview, the kind of things that we would expect to be able to do through the GUI are things like being able to create the Catalyst stores that you're going to use, be able to modify and delete those stores. And the stores themselves are very much like libraries and shares. We allow you to list the objects and list the data jobs and copy jobs that are going on. And we allow you to provide management of the blackout and throttling windows. And we'll look at these in more detail in a moment, along with access control. Now, the reason why this is a relatively sparse list here is because what we're specifically looking at here is putting as much control over the Catalyst stores into the ISV application. So in most cases, we're actually expecting the customers to spend the vast majority of the time managing Catalyst via their backup application, and only really needing to use the B6200 GUI during the initial configuration stage, or if they're wanting to do any reconfiguration. Day-to-day usage we're really expecting to occur through the ISV application. And before we go into the GUI, let's very briefly talk about compatibility. So right now, hardware-wise, we'll be launching StoreOnce Catalyst with the B6200. So it's the StoreOnce B6000 series, and the operating systems that we'll be supporting for the media server installations. So this is where you configure your media server, not necessarily your master server or your cell manager. So we support Windows. Note that it's all 64-bit platforms. There's no support for 32-bit platforms, and there's no support for the Itanium platforms. But we do have support for Windows 2003 onwards, and we have support for Linux versions Red Hat 5 and 6 and SLES 10 and 11. Now, application-wise, you've already heard me talk about HP Data Protector 7. That actually ships with native support, no plugins required. It's there in HP Data Protector 7. That's available now. In addition, we're also supporting Symantec Net Backup 7.1 and 7.5 and Symantec Backup Exec 2012. Both of these will be supported by using an OST plugin, which means you get to do all of the control using the open storage APIs and the open storage capabilities within those two products. And that will seamlessly integrate with the StoreOnce Catalyst APIs. Now, you've already seen me make note of the single node appliances, and that they will have support for StoreOnce Catalyst. Now, as we go through this presentation, we're currently looking at Q1 2013 for availability of those. That is pre-POR, so those dates could move in. Watch this space.